Welcome to this lesson on perturbed C are equations and how they change the KK relations. We'll step through the geometry, the algebra. Welcome to this lesson on perturbed C are equations and how they change the KK relations. We'll step through the geometry, the algebra, and the integral corrections that follow when a tiny epsilon slip is introduced. First, recall the standard C are equation number 1 and C are equation number 2 for a complex function. They guarantee the function is perfectly regular. Now, imagine we add a tiny plus or minus epsilon to equation number 1 only. That leaves us with a tiny mismatch that we will track through the rest of the derivation. Next, we quantify how far the function deviates from being regular. We compute the derivative with respect to the complex conjugate z bar. Plugging in the perturbed c are pairs. The result collapses to plus or minus epsilon over 2. Because the function is not fully regular, the Cauchy integral formula gains a correction term. This is known as the Pompeius-Vecchio formula. The second integral includes our plus or minus epsilon over 2 and represents the spread of the irregularity over the domain D. To reach the KK relations, we sit the contour along the real axis and account for the principal value. Splitting into the real and imaginary parts introduces explicit correction terms from the double integral over D. The real part gains the real part of that area integral, and the imaginary part picks up its imaginary part with the same plus or minus sign. In summary, a tiny plus or minus epsilon in the first C our equation leaves a residual derivative with respect to z bar, which then feeds into a correction integral in the Pompeius-Vecchio formula. That correction survives in the KK relations as explicit area integrals, showing how the system departs from perfect analyticity until epsilon vanishes.